Hello, this is Real World Audio, and this is for all of those audiophiles who are very curious about the science and about measurements. Especially, this is about amplifiers, but not just amplifiers, but about everything. Uh, Although I would say the audio world is focusing about and on the distortion that amplifiers make. And when you read about distortion, it's almost always people are mentioning THD and IMD, so intermodulation distortion and total harmonic distortion. So basically, it's total harmonic distortion that amplifiers are really measured with. And of course, by now, if you haven't been living in a cave, you know that THD, just reading a number, will not say anything about an amplifier's sound quality. You need to know how the THD changes with the changing in audio frequencies and the change in the amplitude, and whether the THD, so how consistent is the change in THD with the change in power level and change in with different frequencies. And when you know all of those parameters, then you can make a more educated guess about the character of the sound. But just by reading a THD value, whether it's like a 1% or 0.0000001%, it's completely meaningless. And now this video is not about THD, but I am throwing in a huge bomb for the audiophile community, is that for all of us who are obsessed with distortion in amplifiers, to open up your eyes and just look the fact in the face that when an amplifier makes alteration to the sound, it's not just that part that which we call as distortion. That's just less than half of the story of the changes that an amplifier is making to the sound. I would say that the other critical part that an amplifier does to the sound is the loss, is signal going missing. That's at least as big of a concern as the distortion, yet almost nobody is ever talking about it. Why? Very easy, because the distortion figures, especially harmonic distortion, is easy to measure with very simple sine waves. You can just squeeze a few sine waves through an amplifier and measure the change. But measuring loss, we don't have any systems, any measurement systems set up for that, and it's not standardized, not quantified. So there is no standardized precedents to work with. But it doesn't mean that the process doesn't exist. It does exist, and it, in my experience, and not just my experience, in many of the audiophiles' experience, it is a very crucial aspect of what or audio components are doing to the sound. And when you look at interviews with Herb Reichert, then he is talking about this aspect of sound and how critical it is. And here I just have a few components listed here, one of them being a resistor, another one being a kudzu cartridge, and just a DSP chip. That any and every component that is in your audio chain has both of these characters to it. So even if you are just looking at a resistor, when there's electricity passing through that resistor, there's two things happening to the electricity. One of which is there's a change. So the alternating signal, because the music is alternating signal, so the signal goes back and forth, back and forth. It doesn't just go in one direction, right? It oscillates with the frequency of the music. And the resistor, as it does not have a fixed resistance for the AC signal. It has a fixed resistance when you have a DC current running through it. But when the current fluctuates back and forth, that's the AC signal, then depending on the frequency and the amplitude, the resistance will be a little bit different. And that's what we call as the distortion of that component. But that component not only distorts, so it changes the AC signal, but there is loss across that component, which means that smaller signals are disappearing, and even larger signals, a portion of that signal is gone. And that's why I'm bringing the attention to loss, because losing a signal or losing part of a signal is an irreversible process. So while the distortion component, there are error correction mechanisms, which most of them are known as feedback, as negative feedback, some sort of feedback mechanism. They are designed and implemented to reduce the distortion. So whatever distortion a component is generating, a feedback mechanism can mitigate the effect of that. However, when there is a loss across a component, that cannot be undone. I hope this really sinks in for everyone, that whatever component you have in your audio system, it's going to suck up portion of your musical signal and make it disappear. And the rest of it that it passes through, it's going to be altered. It's going to be changed. But when we do error corrections on it, which is negative feedback, it's not going to be the exact opposite of that effect that particular component changed to the sound. So that distortion that this resistor added to the sound will not be perfectly undone by error correction. The error correction will do something, but it cannot undo the exact effect that that part introduced to the sound. So even when we use error correction, it still will not restore the purity of the signal before it hit that component. So that's why I made the title Audio World is Half Blind, because we are keeping a totally blind eye to the loss component. That every single part that we introduce into our audio system, it introduces loss as well. Not just distortion, but loss. And if you have, let's say, an amplifier, every single additional part that you add, so if you increase the part count by 1, that will increase the amount of loss that is happening in your system. And that's why I make a cautionary warning against components using hundreds of parts, hundreds of components, against DSP chips, which literally can have millions of components inside, because each transistor is a discrete unit that introduces both loss and distortion to the overall response. And while resistor is a single element, a DSP chip carries thousands upon thousands, millions of those little elements. So this video is basically a primer for the purist audio approaches. I hope everyone has heard about purist systems where the goal is to keep the signal path as short as possible and interfere with the music signal as little as possible. And the rationale behind all of that is to minimize the signal loss to the lowest possible amount. And as you will see, or as those people experienced who have purist systems, the signal loss of those components is order of magnitudes lower compared to a system which is complex to keep the distortion low. Sure, you get the lower distortion, but you cannot keep the signal integrity that you have with a purist system, and the losses there with the very low distortion, very low THD system is that the losses will be quite significant. So thank you everyone for tuning in. Have a wonderful day. Bye bye.